So on to our next problem. At time t equals 0, a cannon fires a cannonball from O that is 4.5 meters above the water at a ship in the distance at A. The cannon fires the ball at a velocity of 100 meters per second. The angle that the cannon fires is at alpha degrees to the horizontal. At time t seconds, the ball is at a horizontal distance x meters and a vertical distance y meters from the origin. Given that tan alpha equals 3/4, show that y equals 3/4 x minus 49/64,000 x squared plus 4.5. Now let me cover a couple of things. The cannon fires the ball with an initial velocity of 100 meters per second. It does this at an angle alpha to the horizontal. We are given a 3, 4, 5 triangle containing alpha, which is here. Because we must break the problem up into horizontal and vertical components, we need to calculate the initial velocity in the horizontal and vertical directions. So, for the horizontal motion, we have u cos alpha equals 100 times cos alpha, which is 4/5, and this equals 80 meters per second. In the vertical, we have this time u sine alpha, and this equals 100 times 3/5 equals 60 meters per second. We must also note that the acceleration due to gravity is minus 9.8 meters per second squared. Now we need to use the Suvat equations, but which one do we use? We use nothing but S equals ut plus half at squared. So let's first consider the horizontal component. You may remember from the previous videos that the acceleration in the horizontal component equals 0. So A equals 0, which leaves us with simply S equals ut, or distance equals speed times time. We are told that the ball travels x meters at time equals t. So write this as, if I do it here, x equals u, which was 80, times t. And we need to make t the subject, so we just divide by 80, divide by 80, that cancels, so we're left with t equals x over 80. Now, moving on to the vertical component of the problem. We have S equals ut plus half at squared. We see in the diagram that the cannon is 4.5 meters above the ground, above the water, sorry. So this is nothing but S equals y minus 4.5. U, the initial velocity, is nothing but 60. So let's plug in the numbers we have so far. So we have y minus 4.5 equals 60 t plus half the acceleration due to gravity minus 9.8 times t squared, which gives us y minus 4.5 equals 60t minus 4.9t squared. And this is equation 2. Sorry, I should have labelled equation 1 as well. T equals x over 60. X over 80 is equation 1. Now let's substitute equation 1 into equation 2. So we have y minus 4.5 equals 60. Equation 1 now, x over 80 minus 4.9 x over 80 squared. And simplifying this, we get y minus 4.5 equals 3/4 x, because 60 over 80 is simply 3/4, and we're left with minus 49 over 64,000 x squared. And lastly, let's add 4.5 to both sides to get y on its own. So plus 4.5 plus 4.5, and we get y equals 3/4 x minus 49 over 64,000 x squared plus 4.5. And this is our final answer. Y equals 3/4 x minus 49 over 64,000 x squared plus 4.5. And there we have it. So continuing on with our question, we now have a couple more things to find. So let's read the new part to the question. Given that we have found the equation y equals 3/4 x minus 49 over 64,000 x squared plus 4.5, calculate the horizontal distance to A and the maximum height that the cannonball reaches at its peak. Firstly then, let us find the total horizontal distance that the cannonball has travelled. Looking at the equation, you should recognise that this is a quadratic equation, and this is good because quadratic equations are easily solved. So firstly, let's write down the equation. So we have y equals 3/4 x minus 49 over 64,000 x squared plus 4.5. Now let's bring the x squared term to the left hand side. So we've got a positive x squared. So this would be 49 over 64,000 x squared. Now bring the x term to the left hand side, so subtract it, so that's minus 3/4 x, and lastly bring the positive 4.5 over, gives us minus 4.5, and this all equals 0, which is what we want. Now we can solve this using the quadratic formula, and you should remember that the quadratic formula is minus b plus or minus the square root of b squared minus 4ac over 2a. And you should be familiar that the b term is the coefficient of the x, the a term is the coefficient of x squared, and c is the constant. So let's plug our numbers in. So we have minus 3/4 plus or minus the square root of minus 3/4 quarters squared minus 4 times A, which is 49 over 64,000 times minus 4.5 all over 2 times 49 over 64,000. Okay, so let's do the maths here. So we get positive 3/4 plus or minus. If you do the calculation of the square root term, you should get the square root of 0.576, and that would be all over 98 over 64,000. So if you carry on doing the maths, you should get two solutions, which are minus 5.84 and 985.4. Oh, sorry about that. 985.43. Because our solution must be positive, we can ignore the negative solution, and so our answer is that the cannonballs travelled a distance to A of 985.43 metres. So this is our answer. Now let's go back to the second problem we are asked. We are asked to find the maximum height that the cannonball reaches at its peak. Now, there are several ways we can do this, but my preferred choice would be to differentiate the equation, finding where the velocity equals 0, calculating x, and then plugging that back into the formula. So let's do this. So if we go down here where there's some space, we have the equation once again, which is y equals 3/4 x minus 49 over 64,000 x squared plus 4.5. Now you should have experience in differentiating polynomials. It's very simple. It's just dy by dx, which this also equals the velocity, so we can put v there equals dy dx equals the 3/4 x term just becomes 3/4, and the x squared term becomes 98 over 64,000, and the plus 4.5 just vanishes. So this is our differentiated equation. Oh, and yeah, and x is there. Now we want the point where the velocity equals 0. This is a maximum value, so all we do is we just equate this differentiated equation equal to 0. So we have 0 equals 3/4 minus 98 over 64,000 x, and now we just solve for x, which is very simple. So if we add 98 over 64,000 x to both sides, we get 98, that is, over 64,000 x equals 3/4. And we multiply by 64,000 and divide by 98. So if I do that to both sides, we get x equals 3 times 64,000 thousand over 4 times 98, and this gives us an x value of 489.80, and this is the horizontal distance at where the velocity equals 0. So now all we do is just to plug this back into the original equation. So y, oh, it's done that again, y equals 3/4 times 489.80 minus 49 over 64,000 times 489.80 squared plus 4.5, and if you do this on your calculator you should get y equals 188.17 meters. So the maximum height that the cannonball travels above the ground is 188.17 meters. And just for the sake of interest, I have opened up what is called Desmos graphing calculator. You can get this if you go to Google, just type in Desmos graphing calculator. And if you see here in the top left, I put our equation in. Y equals 3/4 x minus 49 over 64,000 x squared plus 4.5. Now you see the curve here. Obviously in our question, we don't have negative. So basically our question starts at this point here, the origin, which is, as you can see here, 0 for 4.5. And we can see, we can review our answers. So for example, the horizontal distance travelled was 985 meters, which is what we got. And for the peak height of the cannonball, here we are, 188.17 meters, and this occurs when x equals 489.795 meters. So it's just a good way to illustrate our problem, as we just wrap it up, and you can see, and you can check your answers as well if you use Desmos. So yeah, I hope that's of some interest to you.